Okay, so question 23 says a balloon in the shape of a sphere is being inflated with air so that it maintains its spherical shape. So first we should start out by drawing a sphere. Choose a purple, okay. Make it a sphere, 3D, right here. And so the part A says when the volume of air in the balloon is 288 pi cubic inches, what is the radius in inches? So we don't know the radius yet, so we can just put R right here. So when it says the volume of air in the balloon is 288 pi cubic inches, that tells us V. And so it wants the radius, so we need R. So basically, we can just use, for part A, we can just use the regular volume of a sphere formula for this. So V equals 4/3 pi r cubed. And so we need to find the radius, so that will be that. So V is 288 pi equals 4/3 pi r cubed. So we can cancel out the pi's because they're on both sides. And then we divide 288 by 4/3. And that is equal to r cubed. So then we have the cube root of 288 over 4/3. That works out to be 6. So the radius is 6 inches. So now we know the radius. All right, so then for part B, let's see what it says. At the instant when the volume is 288 pi cubic inches, the radius is increasing at the rate of 0.15 inches per second. So that tells us that dr dt is 0.15 inches per second. And we know that because it says the radius is increasing, so it's not constant. Then it says, at what rate in cubic inches per second is the volume increasing? So they want to know what dV dt is. So then first, we have to take the derivative of the volume formula. So V equals 4/3 pi r cubed dt. Then once we take the derivative with respect to time, implicitly we get dV over dt equals 4/3 pi times 3r squared dr dt. So then dV dt equals 4 pi r squared dr dt. So when we plug that in, we get, we plug our numbers in that we have. dV dt equals 4 pi times 6 squared times the dr dt, which is 0.15. And then we get that dV dt, once you calculate that out, 6 times 6 is 36, times 0.15 times 4 is 21.6 pi. And our units would be, since we're finding volume, inches cubed per second. And if you want to look at that differently, you see here that we have, well, basically, since it's volume, and they gave it to us in inches cubed, we can just know that when we have increasing volume, it's always going to be inches cubed. Okay, so then, if you want to write that out like you would on the AP test, you'd say the volume is increasing at a rate, very important there, of 21.6 pi inches cubed per second. And that would be part B. So then when you get to part C says, suppose that when the volume is 288 pi cubic inches, The balloon is deflating at the rate of 3.6 inches cubed per second. At what rate is the radius decreasing in inches per second at this instant? So for part C, we know that the volume is 288 pi cubic inches. And we now know that dV dt, because it said that the balloon is deflating at the rate of 3.6 inches cubed per second, we know that dV dt is negative 3.6 inches cubed per second, and you get the negative because it's decreasing right here. Decreasing. Okay, so then, oh, my bad, wrong decreasing. Right here, deflating. There we go. So then they want us to, so then here, at what rate is the radius decreasing in inches per second at this instant? So they want us to find dr dt. So that's, we don't know that yet. So we basically can use the derivative from this equation in this problem as well. So dv dt equals 4 pi r squared dr dt. And then when you plug those numbers in, it becomes negative 3.6 equals 4 pi 6 squared times dr dt. And then you get negative 3.6 equals 144 pi dr dt. So then when you come over here, you find out that dr dt equals negative 3.6 over 144 pi. And you can simplify that down to negative 1 over 40 pi, because if you divide 144 by 3.6, you get 40. So then the units here are important because it's a radius. It would be inches per second. And then when you come down here and write this out like you would on the AP test, you would say the radius is decreasing at a rate of 1 over 40 pi inches per second. And you wouldn't put the negative because you already said decreasing. So yeah, that's problem 23. I hope that helped.